Hi guys, happy Monday or Tuesday, depending if you are in an even class or an odd class. This is Mrs. Manley checking in with you for another day of Integrated Math 1. We're going to go over the agenda for today and tomorrow. First of all, County Benchmark. Your grades are updated in Skyward. It will not be the grade that you saw in Mastery Connect. You will receive a grade equivalent to TN Ready's grading system. There were still some of you who did not take the county benchmark, and again, it is a grade and it has a window. If you are on quarantine, you can't just decide you're going to wait till you come back to school to take it, because after a certain point it will no longer be available. I'm looking to see if I can get permission to reopen the test through the end of day Tuesday. So if that happens, and I will have it posted tomorrow morning, which would be Monday morning, if that happens, if you're an even student, okay, if you are in my 4th, 6th, or 8th period, you must get on to take it tomorrow, or you will not have another option. If you're an odd class, you must get on to take it Tuesday, or you will not have another option. EQ6 retakes are now open, and it will be through the end of day Tuesday, which is 3:30. End of day is an end of regular school day. You will just log back into Socrative as normal, so just go to Socrative Student, put in your normal class code, Manley first, Manley third, whatever it is, and just retake the quiz. You don't need to email me to tell me you retook it. I'll check at the end of day on Tuesday and put in the higher of the two grades. If you did not take your quiz in Socrative, you have received a 0 on it. You will be able to take the quiz, but it will be an average of a 0 plus the grade that you get, meaning the highest you can get is 50%. You must go in and take your quiz when you are assigned to take it. LHS Mastery is always due on Wednesdays for even classes and Thursdays for odd classes. You need to purchase graph paper ASAP, okay? Once we get past the EQ we're about to start currently, which is very short, we will be doing a lot of graphing that you cannot just draw your own hand-drawn graph. You must have graph paper. So if you're at home and you don't have graph paper, you need to go get it. And today we're going to start EQ7, literal equations, and have the last of your word wall words. After today, you should have 15 word wall words. If you do not, you need to go on the LHS website, click on departments or on faculty, and find my page, and all of your word wall words are on there because your word wall test will be coming up in just a few weeks. All right, here we go. All right, here are your last 5 word wall words. You have literal equation, which is what we're about to talk about, followed by inequality, elimination method, substitution method, and system of linear equations. We will get through literal equations and also probably inequalities, or at least start inequalities before word wall testing happens, but we probably won't get to the last 3, but these are words that you've seen before, and I put pictures up. So you did systems of equations in 8th grade where you had 2 different equations with an x and a y, and you learned how to solve them using graphing to see whether they intersected, whether they were parallel or directly on top of one another. So one solution, no solution, or infinite solutions. And then how to solve them with algebra using the elimination method, which you see the picture in the top left where you eliminate one of the variables, or the substitution method on the top right, where you isolate and plug in. So please go ahead and hit pause now to copy down your word wall words. All right, today we are beginning literal equations. This is a very quick EQ. We will probably be spending maybe 2 lessons at most on it and then taking our mini quiz. So literal equations are equations that are made mostly of variables, but sometimes will also have numbers included. So we're just going to jump right in. You need your notebook or your dry erase board to get started. So literal equations, solve for a single variable. So our state standard says rearrange formulas to isolate a quantity of interest using the same reasoning as in solving equations. For example, solve P equals 2L plus 2W for L. So we're not really solving equations here. We're isolating a variable to get a variable by itself. So that we'll have, in this case, L equals. So the first thing we're going to do is review changing to slope-intercept form because it kind of follows the same procedure. So either in your notebook or on your dry erase board, go ahead and hit pause and change the current equation on the screen, 3x minus 2y equals negative 16, to slope-intercept form, which is y equals mx plus b, meaning you're isolating that y, and then unpause to see how you did. All right, so welcome back. So I'm going to go ahead and highlight the y. You could also circle it or box it to remind myself that I'm trying to go to the form y equals mx plus b, which means I need to get that y by itself, so I don't need to touch the y. I don't need to move it. The first thing I need to do is get the x on the other side of the equal sign. So it's a positive x, so I'm going to subtract 3x on both sides. I still have negative 2y left over here. Notice it's y equals mx, so the mx comes down first. And then my b, negative 16, comes down next. Next thing I need to do, okay, I still have a y. And it has a negative 2 attached to it now. Okay, so that means negative 2y, negative 2 times y. Opposite of multiply is divide. So I'm going to divide everything by negative 2, which gets me to y equals. A negative divided by a negative makes a positive. We're just going to leave it 3 over 2x because we need a rise and a run because this is slope. And then negative 16 divided by negative 2 makes a positive 8. So again, we didn't really solve for anything here. We say we solved for y. Really, all we did was move pieces of the equation around to isolate y and get it by itself. All right, go ahead and try this next one. Pause your screen. All right, so let's see how you did. So again, we need to get y by itself because slope-intercept form is y equals mx plus b. So the first thing I did was add x to both sides. That's my slope, my mx. Your m in this case would be 1, but in math we don't use the right 1x, we just leave it an x. So that gives me negative 3y equals x, and then I bring down that plus 6. Last step is divide everything by negative 3. So I get y equals, I have an x over negative 3, but remember that's 1x. So since I have a fraction now, I do need to put that 1 back in. So negative 1/3 x, and then 6 divided by negative 3 is negative 2. All right, let's do one more review before we move on to the literal equations. So again, pause your screen here. Work this one out to get it in y equals mx plus b form, and then unpause to see how you did. All right, so again, I'm trying to get y by itself. So the first thing I need to do is move the 9x. It's a positive 9x, so I'm going to subtract 9x on both sides. That gave me negative 7y equals negative 9x, and then bring down the negative 7 right beside it. Last thing is divide negative 7 all the way across. So I get y equals negative 9 over negative 7. Okay, so we're going to leave it as a fraction because it doesn't divide evenly. And then negative by negative makes positive 9/7 x. And negative 7 divided by negative 7 is a positive 1. All right, so let's move on to the literal equations now. So you can see an example over here on the right, v equals pi r squared h, the volume formula. One of the volume formulas, not the volume formula. Normally, formulas are going to be considered literal equations. All right, so for my in school sorry guys, in-person learners, we're doing a foldable, and I know I don't have the ability to get foldables for each of you, but if you want to write down any of this information, feel free to do so. You can always pause your screen to get it written down, change some of the words to make it shorter. So I would title this page, if you are taking notes, Steps for Solving Literal Equations. And the very first thing that I would do if you're writing down the steps is, if you don't want to use the word anchor, I usually say isolate. So isolate the variable. Okay. So the way that we're going to show that we're isolating it is I'm going to highlight it, but again, you can circle it, you can underline it, you can put a box around it, whatever you want to do. So our example that you would write down is I equals PRT, solve for T. So it's asking me to solve for T, so T is what I'm going to highlight so I can anchor it or isolate it. Anchor means hold it in place, like the anchor of a ship holds it in place. All right. Step 2 says evaluate the operations that are taking place to your anchored variable. Right? So meaning look and see what the operations are. Right? So meaning what does PRT mean? Okay? PRT means P times R times T. So I have multiplication here, which helps me with step 3, which is to undo by performing opposite operations. Don't worry about the peel everything off part. The important part is to undo by opposite operations. So again, I don't want to move T, but I do need to move this P and R. And since P and R are multiplication, I'm going to do the opposite, which is divide. And what I do to one side, I have to do to the other. So I get on the left side, I over PR equals, P over P goes away, R over R goes away, and all I have left is T. And I'm done. Because I have I over PR equals T. I have solved for T. T is by itself. Okay, that's all it means. Get T by itself. Okay, let's look at some more examples. Alright, so we'll call this, that was the first example, so I'll call this example 2, example 3, and example 4. Okay. So go ahead and pause your screen, and in your notes in your notebook, go ahead and copy down these 3 examples. Solve for R for I equals PRT, solve for Y and AX plus BY equals C, and solve for A and D equals A plus B plus C over 3. Alright, so we're back, and we're going to go ahead and do example 2 together. So this is just like example 1, but this time it says solve for R. Okay, so I'm going to highlight R because that's what I'm trying to isolate. Again, I'm going to start by evaluating what's connecting P and T to R. All of that's connected by multiplication, P times R times T. So I'm going to divide by P and T because I need R by itself. So I get I over PT equals R, and I'm finished. I just solved for R. R equals I over PT. All right, next example says to solve for Y. So this one's going to have a little more steps. So solve for Y and AX plus BY equals C. So just like a regular equation, we know that before we can deal with the variable that we're trying to solve for, we have to get rid of everything else. So in this case, I have AX, which is being held to my Y by addition, because it's AX plus. Then I have BY, the B is being held there by multiplication. So before I can get rid of the B, I have to get rid of the AX. So this AX, again, is positive. So I'm going to subtract it. I'm going to say minus AX on both sides. Because just like a regular equation, what you do to one side, you have to do to the other. So this AX is gone. BY comes down. And I have C minus AX. Or you could bring it down, negative AX plus C. Depends on you. I'm going to re-anchor my variable here to remind me that Y is what I'm trying to get by itself. All right, so now I have by, meaning b times y. I'm going to do the opposite, which is divide. And what I do to one side, I do to the other. So get y equals c minus ax over b. C minus ax over b. All right, example 4. This one says solve for a. All right, so on this one, I have d equals a plus b plus c all over 3. So if you think back to our last lesson, EQ6, when we learned about solving equations with fractions, we learned that you have to get rid of the denominator. Excuse me, guys, a little sleepy. That you have to get rid of the denominator by multiplying by it. So in this case, my denominator right here is 3. So that means I got to multiply by 3 on both sides. Okay. So on the left side, I get 3d equals. And then on the right side, if you remember from before, we said anytime you multiply by a denominator, all you have left is the numerator. So in this case, my numerator is a plus b plus c. So these 3's go away, and I have a plus b plus c. All right, I'm going to re-anchor my a to remind me that that's what I need. And so now I need to get rid of b plus c. Okay, b plus c, or plus b plus c. So you can either do this in one big step, or you can do it in 2 small steps. It's up to you. Okay, so if I was going to do it in one big step, I would say minus b minus c, because it's plus b plus c. So then I can say minus b minus c on the other side. So I'm going to draw a line down to keep it organized. So b and negative b make 0, c and negative c make 0. So on this side I just have a left. Sorry guys, let me erase. And when I rewrite this, I'm going to move over a little bit here. So on the left side, I have 3d minus b minus c equals a. 3d minus b minus c equals a. If you have any questions on what we're doing, make sure you check in with me and let me know. All right, you guys go ahead and solve the next 2. So go ahead and hit pause and work these out, and then hit play to see how you did. Okay guys, so let's take a look and see how you did. So number 1, solve for L, V equals LWH. So I anchored my L by highlighting it, and I said LWH means L times W times H, so I need to divide both sides by WH, which gave me V over WH equals L. Okay, so pretty quick, simple in there. Number 2 is a little bit more involved. So for number 2, I noticed I had 2 times L plus W. So I chose to divide by 2 on both sides to get rid of that 2, which gave me A over 2 equals L plus W, okay, because I'm solving for W. And then I still had an L that was positive, so I subtracted it on both sides, and that gave me A over 2 minus L equals W. There's another way you could solve this one. So I'm going to do it over here to the left. So A equals 2 times L plus W. Okay, so some of you may have decided to distribute on this one, which is also fine. So 2 times L is 2L, 2 times W is 2W. Then we would say, okay, now I've got A equals 2L plus 2W. I'm trying to get W by itself. Let me go ahead and anchor it. So the first thing that I need to do is go ahead and move 2L. I'm going to subtract 2L on both sides. and I get A minus 2L equals 2W. And then my last step, almost last step, is now I need to get rid of that 2. So I'm going to divide by 2 on both sides. So this takes me to A minus 2L over 2 equals W, which you may be thinking, well, that's a different answer, but it's not. You can actually break that up, okay? A minus 2L over 2 means you're dividing everything by 2. So I could break that up and say, okay, well, then I have A over 2 minus 2L over 2. And if you simplify 2L over 2, okay, the 2's would simplify, and all you would have left is A over 2 minus L, which is the same thing you get over here. Okay, so they are equivalent. There is more than one way to do these problems. All right. Next thing I want you to do is number 3 and 4. I equals PRT, solve for P, and R equals G plus H over 2, solve for G. So go ahead and pause your screen now, work these out, and then we'll come back and work them together. All right, guys, here we go. So let's go ahead and anchor that P. And then I'm going to go ahead and just anchor G as well on the other side to be ahead of the game. All right, so I equals PRT. We've done this one, solving for every variable now. PRT means P times R times T. So the opposite is divide. I'm going to divide by RT, and I get I over RT equals P. Okay, done. All right, number 4. Again, we can't do anything with a fraction, so we've got to multiply both sides by that denominator. So I get 2 times R is 2R. When I multiply a fraction by its denominator, all you have left is the numerator, which is G plus H. Let me go ahead and re-anchor a G. And now the only thing I have left to do is get rid of that H. So it's G plus H, so I'm going to do the opposite, which is minus H on both sides, or subtract. So I get 2R minus H equals G. Let me go ahead and erase the screen. All right, so what I would like you to do from here is go ahead and work equations, literal equations 1 through 5. Okay, literal equations 1 through 5. Pause your screen, work those out, see how you're doing, and then unpause to go back and see how you did, and then we'll continue with the lesson. Okay, so we're just going to take a few minutes out to do some practice. All right, guys, here we go. Let's see how you did. For number 1, again, we've done a ton of these so far. So I anchored T, and I divided by PR on both sides to get I over PR equals T. For number 2, started by removing that 2 and the 2 times L plus W by dividing both sides by 2. That gave me A over 2 equals L plus W. Then I subtracted W on both sides to get A over 2 minus W equals L. Again, feel free to pause, rewind, fast forward, whatever you need to do as you're going through these to see it again. All right, for number 3, 2W plus 4 equals XG, solve for G. Looking at that one, it looks like it would be really hard, but the only thing with G is X, and XG means multiply, so we're going to divide both sides by X. And in one step, we're finished. 2W plus 4 over X equals G. Number 4, Y minus 6 equals X, solve for Y. So I anchored my Y, added 6 on both sides, and I'm finished. Y equals X plus 6. So again, another one-stepper. And then number 5, X plus Y over 3 equals 5. I have to start by multiplying by the denominator. So that gives me just x plus y on the left and 15 on the right. Subtract y on both sides, and x equals 15 minus y. All right, so the last thing we're going to look at today are some T and Ready style questions. Basically meaning these are the types of questions you would see on quizzes, tests, or T and Ready. So your first one here is a bit tougher one. Okay, this is the toughest one I've given you. Consider the equation where p is a real number coefficient. Negative 1/3 px times px minus 2 equals 9. What is the value of x in the equation? So meaning get x by itself. All right. So when we rewrite this equation, I want us to think about what it actually says. So this is saying negative, sorry, my pen stopped. Okay, negative 1/3, okay, times px minus 2, which would really be like px minus 2 over 1. So if I multiply straight across, 1 times px minus 2 is just going to be px minus 2, and 3 times 1 is 3. And then we just have to remember that it was a negative 1/3. So since I don't have the 1 up here anymore, I'm just going to put my negative down here on the 3, because it was a negative times a positive, so it still needs to be negative. Okay, so I have px minus 2 over negative 3 equals 9. All right, so far all I've done is rewrite it to what it actually looks like, okay? Because it wouldn't be fun to distribute a negative 1/3 times some variables. Now I need to get rid of that negative 3 in the denominator, and we know to do that, I multiply both sides by the denominator. So on this side it just goes away, and all I have left is my numerator. Px minus 2 equals 9 times negative 3 is negative 27. Now, I didn't anchor my variable, so let me go back and do that. So I'm trying to get x by itself. What is the value of x? Here's my x. Here's my x. All right, so next step, I got to get rid of this negative 2. So I'm going to add 2 on both sides. Now I have px equals negative 27 plus 2 is negative 25. All right, still have to remember I'm solving for x. So I've got to get rid of that p. I'm going to divide both sides by p. And I get x equals negative 25 over p, which is this option right here. Okay, feel free to watch this one again if you need to see it again. It is the toughest one we've looked at. Right, the equation for the area of a circle is a equals pi r squared. Excuse me, guys. Solve the formula for r. All right, I'm going to rewrite my equation. And I'm solving for r. I'm going to anchor my r. All right, so I have a equals pi times r squared. So pi r squared means pi times r. So the first thing I can do is divide by pi on both sides. So now I have a over pi equals r squared. Now, here's where you got to think back to 8th grade last year and help yourself remember some inverse operations. R squared, okay, has an inverse. What is the opposite of squaring a number? Okay, for example, if I had 2 squared equals 4, I squared it to get to 4. So what would I do to 4 to get back to 2? The opposite of squaring something is taking its square root. So I have to take the square root on both sides. Okay, so that's going to leave me just r on my right side. So I have anchored and completely isolated my r. And then on the left side, I just leave it as it is, the square root of a over pi. And if I look, r equals square root of a over pi. That's answer choice D. All right, solve for h. A equals 1/2 h times a plus b. Let's go ahead and anchor. So I'm solving for h. Okay. This one, when I rewrite it, I would rewrite it like the one we did 2 problems ago. So 1/2 h times a plus b is really saying h times a plus b over 2. Okay, if you need to see that, I can show you. So it's really saying 1/2 times h times a plus b. So 1 times h plus a times 8. 1 times h times a plus b would just be h times a plus b. And then 2 times 1 would just be 2. So I get h times a plus b over 2. So if you can just remember that if you have a fraction with a numerator of 1, it's really saying you can put everything it's multiplied by over the denominator, which in this case is 2. So I have a equals h times a plus b over 2. Oops, I can't get my highlighter to come up. There it is. Alright, so I got to remember I'm trying to get h by itself. So now I have to get rid of that 2. So I'm going to multiply by 2 on both sides. That gives me 2a. And then remember, when you multiply a fraction by its denominator, all you have left is the numerator, which is h times a plus b. So again, I just need to remember I'm trying to do my h here. So now all that's left is the times a plus b. So I could divide by a plus b on both sides. And I get 2a over a plus b. Notice it's a capital A on the left and a small a on the right. So 2a over a plus b equals h. So again, remember, these are a little bit tougher questions because they're meant to be more rigorous as they're T and Ready style questions. All right, consider the equation where j is a real number coefficient. 3 times jx plus 3 equals 15. What is the value of x in the equation? So this is still considered literal because you're solving for a variable, but this one is mostly made of numbers, and it's similar to one we did earlier. So I have 3, and again, if I'm ever moving too fast, remember that you can hit pause to copy your problems down and then come back in. 3 times jx plus 3 equals 15. Right? Right off the bat, I need to get rid of that 3. So I just have jx plus 3 equals 15 divided by 3 is 5. I go back in and anchor my variable so I can remember what I'm solving for. I'm solving for h. So now I have jx plus 3 equals 5. So I'm going to subtract 3 on both sides to get jx equals 5 minus 3 is 2. Again, it's still x that I'm trying to get alone. So jx means j times x. The opposite of multiplying is dividing. So I'm going to divide by j on both sides. And I get x equals 2 over j. Alright, so that's literally the end of this lesson. So we will probably do some kind of, quick review on Wednesday, Thursday, and go ahead and quiz because this is a quick one. You do have an exit ticket to complete. You're just going to worry about completing 3 and 4, which I'm going to say are 1 and 2. Okay. And you can do these on your LHS Mastery. On the same page you do your LHS Mastery on. Either write exit ticket at the top and do 1 and 2 and then do LHS Mastery below it. Or do LHS Mastery at the top and exit ticket below it. It's kind of up to you. Alright, have a great day. Email me if you have any questions.